Welcome, everyone. The goal for today is to go through quite a bit of material, and our agenda for this morning is starting around now. We've got a lot of very interesting, exciting things to talk about in terms of technology trends that are happening in BC and Canada and beyond. Talk a lot about some various technologies you probably are very familiar with or have heard about or are seeing in the news. Talk a bit about some interesting things around what are called unicorns, companies that achieve a billion-dollar valuation or more here in BC. We've had some amazing things happen this year. Take a bit of a break and we'll come back and talk about some of the impacts of these technologies hitting real-world industries, and then get to the meat of what we want to really impart upon the teachers and folks like yourselves are the careers and technology opportunities for students, and then a chance for some question and answers. So this program with BC Tech Association and our funding partners and industry partners is really around helping to increase the number of students going into technology careers, and in particular, helping to drive the number of girls and underrepresented individuals going into this industry. And our goal is to begin the process now to work with you to reach out to students as young as in kindergarten, but all the way through grade 12. And again, we're very hopeful that today we can provide some valuable and relevant information to you, the teachers, so that you can bring it back to your students, faculty, and staff. So for today, again, we're going to share some big trends that are happening globally, locally, review some key technology concepts, provide some insights into the wide range of technology careers available in this industry, and again, hopefully make it fun and relevant and inspire you to, again, bring this back. So to kick it off, we're going to talk a little bit about data, some technology trends globally, nationally, and locally, and again, hopefully provide you some things you weren't aware of before. This, however, is probably things we've seen. In particular, there's we'll have a pandemic theme a little bit here and there, not too much, but certainly we've all experienced in the last 18 months with COVID how technology has reshaped so many things. But this had obviously started decades ago. Technology as an industry is dramatically reshaping almost every industry across the globe. So here's some interesting statistics. So Uber, which is effectively the world's largest taxi company, doesn't own any vehicles. Tens of 100 million plus riders, millions and millions of drivers. They don't own a single vehicle. Airbnb is the largest accommodation provider in the world, yet they don't own a single piece of real estate. Facebook, love them or hate them, is the largest global media provider, but they don't create any of their own content. They could do a better job of moderating the content, as we're seeing, but they don't create any content. They are really just a platform. Instagram, owned by Facebook now, but really is the most valuable photo company in the world, and they've never sold a single camera. Netflix, the fastest growing television network, has never laid any television cables or cable infrastructure. And Alibaba, if you've heard of Alibaba or not, they're a Chinese-based company. They're the most valuable retailer in the world, yet they hold no inventory, not a single piece. And what's crazy is that none of these companies existed just 20 years ago. All of these companies have been created through the power of technology. So what's interesting as well is when we look at what we often called, a technology getting to ubiquity, or really the time it takes an innovation to reach 50 million users in years. So if we go back in history a little bit, airlines and automobiles, airlines took 64 years to reach 50 million users or people. Automobiles took 62 years. The telephone and electricity took 50 and 46 years. And then, big chunk more here, credit cards, TV, ATMs, computers, and mobile phones took from 28 down to 12 years. So again, each of these technologies in some way, may have a reliance on a technology that came before it, but you can see the speed of adoption is increasing. And then the internet took just 7 years to get to 50 million users. Facebook took just 4, and WeChat took just 1 year. Pokemon Go, if you remember Pokemon Go, that game, took just 19 days. So the infrastructure around technology has enabled this obviously interconnected world that allows innovation to spread insanely rapidly and really bring powerful technologies into the hands of people very, very quickly. So it's very important, of course, when we go back to you, the educators in our youth, is that STEM skills are now associated with 75+% of the fastest growing occupations, which of course make it very, very important in our school system to address that. Over 40% of today's jobs are impacted by automation, and over the next 15 years, that impact will grow. It's already accelerating. It'll probably be more than 40% in under 10 years as we see the adoption of these technologies increase. So really, it's understanding these trends and these technologies to provide insight into how we can prepare our current and future students for the changes and opportunities ahead. And that's our big goal here today. So these impacts are inevitable. And again, we want to empower you to enable students to be part of the positive change that is coming about in this world. So what are some interesting things as well? In the Canadian tech sector, we're going to provide you some statistics. There's now over $193 billion in Canada of total revenue that drove $86+ billion of GDP in 2018. That, it's a huge, huge contributor to the overall Canadian GDP just from the tech sector. In 2018, this grew by 3.7%, which for the tech sector, it outpaced the economy that only grew by 2.3%. So that's a 61% increase. So the tech sector grew by over 60% faster rate than the rest of these sectors in Canada. In Canada, and again, these are 2018 stats, so we'll talk a bit about post-COVID, but in 2018, in Canada, we employed over 650,000 workers in the tech sector across over 41,000 companies, in the nation. So again, when you do the math here, and you'll see this in BC as well, it does tend to be an industry of small, medium business. There are some very large companies, but when you do the, you divide here, this does really show that it's a very, very diverse population of companies. And what's very interesting is that in Canada, the average salary for a tech worker is about 50% higher than the Canadian overall average. So again, one of the things we're here to talk about with you is to help make it interesting, but also valuable for students to consider going into the tech industry because it pays very well. Now, how do those similar trends translate into the local economy here in British Columbia? Well, the tech sector is one of the fastest growing in BC. It is the third fastest growing contributor to overall provincial GDP and drove more than $29 billion in annual revenue in 2018. BC is the #1 startup ecosystem in Canada and the top 15 globally. So what does that mean? Well, a startup ecosystem is really around all of the various players that come together to contribute to startups being able to grow. This is industry, this is academia, this again is not-for-profit associations like BC Tech and others. So it all comes together to really form a foundation where in BC, we're seeing it being a fantastic place to start and grow a tech company. Again, if you remember the previous stat in Canada where tech sector wages were higher by 50%, in BC it's 84%. So in BC, on average, a tech sector worker earns 84% more than the provincial average. That is huge and such a great opportunity for our youth. And again, we're employing in the tech sector over 114,000 people across 10,000 tech companies. So again, even more so in BC than nationally abroad, we are a province of small, medium businesses, a lot of startups that are high growth companies that are employing a lot of people. So again, a huge opportunity. And again, this stat, and we'll talk about the impact of COVID, but tech jobs in BC in this year were forecasted to be over 196,000. So again, there's been an impact of COVID, but we'll see actually next year where the stat actually ended up. But in Vancouver alone, we created over 14,000 tech jobs from 2017 to 2018. That's a lot for one metro area. And again, very proud of that. But a very interesting stat in BC is that the tech sector employs more people than mining, oil and gas, and forestry combined. That is a very surprising stat to most people, given that we've been a resource economy for so long, and the tech sector is really a fast growing, coming up out of nowhere in some ways, now employing so many people. And again, another great stat from about a year ago, just under a year ago, Vancouver was ranked #1 in tech job growth in North America. So this stat is done by CBRE, the big commercial real estate company. The previous year, we were also #1. So that meant, again, over that 2-year period, Vancouver grew 29.2% in tech job growth. This is compared against Toronto, Ottawa, Seattle, Silicon Valley, San Francisco, Los Angeles, New York, Austin, Texas. So, that is phenomenal. There's a lot of talent coming here and a lot of influx of companies. So let's talk briefly about some of the impacts of COVID. We've got some different data sets here, more coming. But across Canada, if you can see sort of the chart here, broadly, the gross domestic product or GDP for Canada, you can see how it dropped so rapidly with COVID back in sort of March, April, May of 2020, and then recovered and started to crawl back up. When you compare that to the tech sector for the same time period, you can see that it dropped, but it quickly recovered and actually exceeded where it was by around about May of 2020. And in BC, it's already recovered well beyond it, and we're already growing well past that. Another stat we'll kind of look at. You don't have to interpret this, but you can just sort of see again the overall ICT or the technology sector growth. You can see how the blue line along there's a little more volatility with the overall Canadian GDP spike, drop, and then go back up. But the tech sector, which is that blue line, has continued to trend along, and it was barely a blip with COVID. And that's pretty phenomenal and demonstrates again the resiliency of this sector. A couple more quick things. Really the data here, what's very important about this is during COVID, that top blue line in the left chart is just that the ICT or tech sector grew from January to December of 2020. And actually, whereas a lot of other sectors, in particular, the very bottom, very sadly, accommodation food services dropped dramatically. But the tech sector actually grew through the whole of 2020. And then as well in, how the actual digital occupations, everything from computer programmers, web designers, UI, user experience designers, which we'll talk a bit about later, all of these grew during that 2020 time period. So to summarize some of this, the tech sector is one of the most resilient. Again, during that initial couple of months of COVID, there was an initial 4.2% decrease and nearly a full recovery by May of 2020. During that summer of 2020, in our data in BC is that 50% of tech companies in BC continued to hire during the pandemic. Past that summer, it grew even further. But during that initial pandemic period, 90% of BC tech companies did respond quickly and cut costs, and 60% of them pivoted their business in some manner. But the benefit again of being a tech company is that most tech companies are already set up to manage remote work. And so it was very easy for companies to say, hey, stay, work from home, remain productive, et cetera. What we've also seen, though, is a massive demand, an increase in demand for information technology, e-commerce, cybersecurity, e-learning, and online services. And that has continued to grow, even as we're moving through the pandemic here. All of my colleagues are scrambling to hire people. It's actually become very challenging to hire people because of the need for good, talented folks. So to finish off this section, the key takeaways, the growth in the technology industry is massive. It's having a significant positive impact on revenue, GDP, job growth, and employment income in British Columbia and beyond in Canada. Jobs are being created at a faster rate than our current schools are producing qualified candidates. Again, one of the main reasons we're here is to hopefully inspire you to bring this message back to your students and help them find their way into tech careers. BC is an absolute national and world leader in the tech sector. We provide unprecedented opportunity for our next generation of young people to come into this sector. And again, collectively, we want to help start now to understand how to prepare our students for these changes and for the demand for tech-savvy jobs. And again, at the end of the presentation, we'll come back and talk about some of these jobs and opportunities, because it's not just about computer programming. So this next section here, we talk a lot about technologies and trying to demystify things from AI, artificial intelligence, through to quantum computing and more. This tends to be a alphabet soup of buzzwords. We're going to talk about all sorts of different technologies. You may have heard of many of these. You may be very, very familiar with some and less familiar with others. So we're going to go quickly through sort of tops of waves, about 12 or 13 of them. So in pseudo alphabetical order, we'll start with AI and machine learning. So again, we've all been exposed to this, artificial intelligence, machine learning, just to provide some definitions, because they are a little bit different. Artificial intelligence, from a definition standpoint, really is the ability of a computer program or machine to think and learn and start to act like how a human brain processes information. Machine learning is a subset of AI that uses math and statistical models to perform a specific task without instructions, and instead uses, again, math to rely on patterns and inference to make decisions. So really, AI and machine learning together are about helping a system use data to produce outcomes and drive results in a way where it can almost learn on its own. So there are so many applications of this. Again, Canada is a world leader in this. The massive growth in artificial intelligence came at a spike in 2012 when there were some breakthroughs in image processing driven by a couple of Canadian researchers. And so we are very much well known globally as world leaders in AI. Some of the applications are around technologies like computer vision. So again, this is the ability for a artificial intelligence system to look at images, whether they're still or videos, and make sense of them, understand or do what's called object detection. So detect objects inside of an image or a video, make sense of them, understand what's happening. Another technology, natural language processing, or what they call NLP, is the ability for an AI system to read human language and understand it. In around actually October or so, September, October of 2019, natural language systems finally met and started to exceed a human's ability to read and understand written and spoken language. Natural language processing systems can now actually also produce written content that is indistinguishable from a human writer in most cases. And the third sector, deep learning or neural networks, is again really the ability for a system to look at patterns of data and make sense of it in mass volumes and at speeds that, again, humans typically can't do it. So huge opportunities for improvements across so many industries, whether it's speech and handwriting recognition, facial recognition, object detection, processing images, applications like medical diagnoses, the ability for AI systems to look at, COVID scans of lungs, cells, cancer cells, all sorts of things. The medical applications, huge, being able to read and understand, volumes of medical journals and make sense of them, whether it's in marketing or sales support. So the company, the Vancouver company Dooley, that's gone on to raise tremendous amounts of money in the last couple of months, they have an AI-based sales enablement platform. So they tie together data from multiple systems that then help salespeople make more efficient sales. Predictions, you'll be able to predict trends in markets, being able to predict. There's a company in Toronto called Blue Dot that actually predicted COVID 2 weeks before the CDC became aware of it by reading global sets of news data. So again, AI is quite powerful. Next thing we're going to do is show you a portion of a quick video that shows how a technology called GANs, or generative adversarial networks, can use images to interpret and create other images that haven't existed before. So we'll run this for 30 seconds to a minute, and we'll move on to the next one. So what you're seeing here, which is fascinating, is by using a control image in the bottom corner and control images across the top, by adjusting these control images, they're able to create and generate images that never existed before by creating a composite of all of these images together. So while this has some very, very interesting marketing applications, there's also incredible applications of this technology in medical science. So being able to take images of cells and scans of patient records, and then creating versions of them that haven't existed before. You can actually use AI to detect anomalies without having to get personally identifiable patient records, as one example. Now, you may have seen this technology used in what they call deep fakes as well, which are a negative use of this, but there's also this technology being used in deep fake detectors. So very, very, very powerful and compelling technology being used in many, many areas now in incredible ways. The next technology we're talking about is sort of a mix of augmented, virtual, and mixed reality. Now, I know many teachers are using this actually in the classroom or seeing it and playing with it in visual arts programs and in other areas, computer science. So just to define some of these again, augmented reality is a technology where there's content that is overlaid on the real world, but that content isn't necessarily anchored to the real world. Instead, it appears like a visual layer through a lens. So the best example of this we talked about earlier is Pokemon Go. So if you ever played Pokemon Go, or you saw your students, your kids use it, they were using their phone, the camera on their phone, to look at the real world, and there were objects or characters appearing on top of the real world. Companies like Nike are using this to do shoe drops. When they drop a new shoe and there's a limited edition of them, they do a little puzzle or a game, and people have to go into the real world and solve a puzzle and go to a location where they find it. And so the players playing the game are actually looking for clues overlaid on top of the real world, and they find the stash and allows them to buy the unique shoe, and there's only one of 20,000 or whatever the number happens to be. Virtual reality, by contrast, is an immersive experience where the user is inside computer generated content. So if you've used or tried the Oculus headset, where a headset goes on and you're seeing a virtual world and you're interacting only in the virtual world, that's an example of pure virtual reality. Mixed reality is sort of a synthesis of these two things, where there can be a real world set of content overlaid by synthetic or virtual components. And so again, if you've used Microsoft's HoloLens for this, this is where again you can have a human interacting with virtual items that are anchored to a space and a location in space and time in their field of view. One great example of this for a local BC company is Precision OS. They're using high fidelity virtual reality systems to help train surgeons to practice procedures, not on real patients. So they're able to actually have doctors and prospective doctors put glasses on and actually use gloves in their hands to work on a virtual patient and have them sort of guided by a doctor expert. This is being used for very specialized surgeries where there's only a handful of doctors around the world that know them. It enables them to train doctors anywhere in the world, having to fly around and and go through all the cost and expense of that, and also allows people to be retrained or get advice very quickly. Phenomenal application of that. Another quick video here, we're going to show more of a fun example of how some of this mixed reality works for a brand you may know.
privilege for all who can witness this. I am close to divine. Know the moment is mine, the moment of sign. I sprint. To all the squares that ask around, we getting it. My skills pay me. Trying to get a million, baby, with an adopted flow that God gave me. Tell whoever runners that they spot is temporary till I
think I got that one.
Tell Miss I'm on my wealth tip. So when we cash out soon, I'm just investing.
I'm telling you, this is how it works, man. There's a little camera right here.
So very interesting example. That one's a little more fun, but it kind of gives you a concrete view of how this actually, can kind of all work. So moving through quickly into our next one, blockchain, very powerful technology. And we've sort of updated this presentation a little bit to bring in a little bit more about cryptocurrencies, NFTs, and DeFi. We'll talk a bit more about those in detail. Certainly, you've probably heard about some of these things in the news as of late. To start off fundamentally here, what is it? Well, blockchain as a technology is an open distributed ledger system that can record transactions between parties efficiently and in a verifiable and permanent and generally a very public way. So what does this mean? Well, in a traditional computer system that is managed by a database, so for instance, if you make a purchase on Amazon, Amazon has a database that stores all these transactions and really only Amazon can see them. In a blockchain world, similar types of transactions can be recorded, but they are on a public and verifiable system that, again, is very transparent. So the benefit of this, there's many, we'll go through it in a couple steps here. Blockchain is used as a foundational component for cryptocurrencies like Bitcoin, Ethereum, and others. The reason this is valuable is that it allows a immutable element of technology. So if I transfer a Bitcoin to a retailer to make a purchase for something, the fact that I own those Bitcoins is provable, and the fact that I transfer them is provable and verifiable. One of the reasons it's able to do that is there are effectively copies of this ledger distributed around hundreds, thousands, tens of thousands, or millions of participants in this network, so that it's very, very difficult to disrupt, very, very difficult to hack, and very difficult to disprove or get in the middle of a transaction. So it makes it very powerful to create high-scale distributed systems that have a lot of trust in them. Blockchain technologies also layer on things like what are called smart contracts. Smart contracts make programmable contracts in software. So great examples of this are things like an insurance or a real estate contract. So today, if you have a real estate contract, you have to go buy a house from someone. There's physical copies, or maybe email the copies of these things around, but they still have to have intermediaries control them and manage them. A smart contract can actually have all of the contract elements embedded in software. So they could even say, hey, once this contract is complete, pay out these commissions or move the money from here to here. And all of this is embedded in again, blockchain where it's immutable, unchangeable, and transparent. So there can never be any disagreement as to what the contract was, and no disputes around it. This makes it very valuable for banking and financial service transactions, again, because there isn't a, this person said, that person said dispute. It's all out in the public and you can't change it. Some very interesting, powerful future transactions and applications include governmental things like identity and voting and land titles. So right now, there's a lot of work being done around identity, because if everyone could have an immutable, unchangeable, identity that was absolutely verifiable and trusted, it would get past a lot of the challenges we have with identity today. That's particularly applicable to things like voting, participating in all sorts of, voting style, schemes and different things. So whether it's an election or whether it's, your strata council voting or whatever it happens to be, very, very powerful. Land titles as well. Right now, we're all kind of beholden to like, one or two or a handful of land titles organizations that have to keep records of who owns what. But this, is a much better application to live on a blockchain where it can all be programmatic at a much lower cost and much faster. We've probably, a lot of us have heard about things like non-fungible tokens, NFTs. I'll come back and talk about that in a minute, but also technologies like decentralized finance or DeFi. All of these technologies are being made possible through the power of blockchain, again, by having these transactions on a ledger that are public and available and unchangeable, really allows all the stuff to happen and be decentralized. So this is changing our banking infrastructure. It's changing how we do financial transactions between an individual and a business, or between individuals. Very, very, very powerful. Local BC company called Dapper Labs has been at the absolute forefront of this. They have a number of products that provide things like everything from, this is just one example, real-time immutable tracking for streaming music plays, to non-fungible tokens and characters, to a product called NBA Top Shots. So they've raised hundreds of millions of dollars in the last couple of months. One example, we're going to talk about them a couple times. One example of another product they have is NBA Top Shots. Is they've enabled the NBA, the Basketball Association, to take their photographs of key moments in games and make them unique and monetize them using an NFT. I'll come back in a moment and mention that. But Dapper Labs has been at the absolute forefront of this. So quickly, a couple of interesting things, and this is an eye chart, so no need to read it all, but there are so many uses of blockchains around the world. We've talked about a few of them: government, identity, land titles, real estate transactions, financial transactions, insurance, mobile payments, but there's so many more. There are companies looking at this for carbon offsets, so properly tracking carbon offsets, or areas that are called in the emerging market of ESG, or environmental social governance transactions, keeping companies on how they do environmental compliance. There's all sorts of advertising opportunities, so tracking when ads were actually played versus not played. There's energy management around, again, how energy is tracked and used. There are cybersecurity components. There's amazing things for blockchain being built. The other powerful thing with blockchain is it started off as sort of the biggest challenge, is it being kind of slow to transact, and we're now seeing some very powerful emerging technologies like Solana and Cardano being very, very high frequency and high throughput. But maybe just to kind of quickly talk about NFTs, or non-fungible tokens, because you may have come across this in the news or heard about it. So what is a non-fungible token, or an NFT? Well, the definition really is that a non-fungible token is a unique and non-interchangeable unit of data stored on a digital ledger. So that's a lot of gobbledygook. So what does that really mean? It means that you can take a digital asset and create a provable, unique and traceable element to this, such that you can actually show what they call provenance, or true proof of ownership. So it uses the blockchain to be able to say that this digital asset is unique and owned by a particular person, or a particular a company, and you can actually show the entire history of the ownership going back to the creation of that digital asset. So it's being used now primarily in collectibles and art, but a tremendous number of other real world applications for it. But things of like photos and videos and audio. And it's really, what's powerful about this is that these things are being created, bought, and sold online using cryptocurrency, so Bitcoin, Ethereum, Solana, and others. So the ones you may have heard of are the two biggest ones, which are crazy and hard to wrap your mind around, is that the top one is an actual piece of digital art that was sold by a digital artist named Beeple for $69 million through an art auction in March of this year, of 2021. That piece of art was called Every Days, the First 5,000 Days, and it's a collage of 5,000 images going back, a piece of art that Beeple created every day for 5,000 days. So this goes back, I think it's to 2007, and he made a collage and sold it for $69 million. It is a digital piece of art. It's not on a canvas, it's not physical. So the question you might ask is, well, couldn't I just create a copy of this and have my own copy? And the answer is you could, but you wouldn't have the authentic or original verified version of it. So much like in the art world, where there are copies of other pieces of art. There are, scams and artists that create copies of things, and that's constantly been a challenge in the art world. This NFT technology now enables the same benefits of physical art, but in the digital world. The one beneath it is even a little more mind-boggling. This is what's called a CryptoPunk. And it literally is what you see. It is an image of a human in this kind of 8-bit art. This CryptoPunk, number 7523, out of a sequence of, I think it was 10,000, sold for $11.75 million US in June of 2021. And many of these are selling for millions and millions of dollars. And it's very, again, hard to kind of wrap your mind around, but it's happening, and it's a whole new world. So what's really driving a lot of this is that young people, and this is why this is very germane to our students, young people are digital natives. They understand this technology. They are used to having digital goods in games that have value. A recent study came out that said, young people, sort of the current generation of Gen Z, actually value their online persona more than they value their real world persona. So they start to understand the value of having all of these digital goods. You're now seeing NFTs being created for, again, either characters in games, or your sword in a game, or a particular good you've acquired or grown in a game, be able to buy and sell them and move them around to other people in a game or between games. And that this NFT technology is what's enabling that. And what's really interesting is that from an art standpoint, digital artists have been around for a long time, but they've, because their art has been copyable instantly, they've been paid in likes on Instagram, not with any sort of currency. And now, again, this NFT technology enables this whole new world. It's fascinating, incredible, and moving fast. Some other real world examples of NFTs are, concert tickets. Again, if you've ever had to deal with Ticketmaster on concert tickets, and being able to verify that if you need to sell your ticket to someone, and you have to resell it through Ticketmaster to maintain the authentic, that it's authentic, Ticketmaster has made a lot of money on that. It's a perfect example for an NFT. You should be able to create an NFT for your concert ticket and be able to transfer it to other people. This whole metaverse and areas that people are talking about, again, digital goods and assets are growing massively very quickly. And again, a huge opportunity. Young people are making money off this. Creators, my grade 10, my 15-year-old, she's starting to do digital art and wanting to make them into NFTs. So we're showing her how to do it. And she may be able to sell them, maybe able to make some money on it. We will see. Fascinating. So to move on kind of quickly here, the next section we'll talk about is digital health. Again, we've all experienced this in the last 18 months with COVID, but really, what is digital health? It's the use of information technology and electronic communication tools and services to process and deliver healthcare, to make our lives better. So probably most of us have had a virtual healthcare appointment in the last 18 months. So instead of going to your clinic, instead of having to wait in line, you can now sign up and subscribe and get an appointment time, and then use a mobile app to actually, connect with a doctor. But outside of that, patient produced health data from smart wearables, whether it's your Apple Watch, your Fitbit, your Aura sleep ring, emerging, there's an emerging category now of, blood glucose monitoring devices that traditionally were only available to diabetics and pre-diabetics, now being available to anybody to track their blood glucose through an app. And that's having dramatic improvements in people's diets and attention to their health. But also remote patient monitoring tools, being able to track elderly people in their homes or in facilities to make sure that they are alive and well and moving and taking their pills. All of these types of things are fall into this digital health realm. Local Vancouver headquartered company Well Health has grown very rapidly in the last 4 years to a multi-billion-dollar valuation by bringing together many healthcare clinics under one brand, and then also applying electronic medical records technology system to them, and then enabling virtual healthcare platforms on top of that to deliver amazing technology. They've done phenomenally well. Another one, CloudMD, and of course you've probably also seen TELUS with with their virtual doctor platform coming to market as well. The next technology is an interesting one. You may not have heard this one, but you've probably seen bits about this. It's called digital twinning. Digital twinning is where a digital replica of a living or non-living entity is created to bridge the physical and the virtual world. So this is where, again, data from a digital twin is transmitted seamlessly back to a system and between a virtual entity and back to a platform where they can interact together. And I'll show you a video to make this very concrete. There's a lot of value for this in manufacturing and enterprise resource planning, the ability to manage remote facilities, doing 3D visualization, doing what are called collaborative walkthroughs. So this is really powerful. So imagine, being able to have a digital twin of a factory that you could virtually walk through to look for deficiencies and look around and see how things should be laid out and placed without having to actually send someone to a factory. The huge benefits here is being able to reduce risk for workers, be able to prevent downtime for machines that can communicate back and forth. And again, a great company here in Vancouver doing that is called mCloud. They are doing 3D digital twins for energy facilities. So again, if you can imagine being able to create a digital twin of an energy, like a hydroelectric turbine, and see how it performs virtually before actually creating it. And again, this is sort of maybe hard to wrap your mind around. So we have got a quick video. We'll show you a part of this video next to really make it concrete.
Digital twins, the innovation backbone of the future, delivering virtual representations of real-world products, systems, and cities. For example, the digital twin of an electric motor not only showcases form, but also analyzes functions, from the rotation of the shaft to thermal conductivity to data from sensors and beyond. What's more, the digital twin continuously evolves, thanks to the flow of data, user experience feedback, and new input, and it's greatly impacting development, production, and operation. In development, a product's behavior can be simulated and tested long before a physical prototype has been built. Siemens utilized the digital twin to develop a world record-setting electric aircraft motor that not only weighs 50 kilograms, but is also 5 times more powerful than comparable electric motors.
So that is an incredible advance right there. The ability to be able to simulate these things in software before you produce them, again, saves time, money, all sorts of things. We have another video later that will show another application of this that's very close to BC industry. The next technology here is what we call the Internet of Things, or IoT. You may have heard of this. This is really when there's a network of interconnected things or devices or sensors that come together to collect data, transmit them back to a system, and help help individuals and systems be responsive and adapt to things around them. So this is often combined into things like connected devices. So cars, a lot of cars today are already transmitting data back to a network, being able to transmit data back to a home system that helps them adapt and understand what's happening. Refrigerators are now actually transmitting data, the temperature inside a refrigerator. There are lots of refrigerators now coming to market that have cameras inside them that can actually look at what's in the fridge and then actually produce things like a shopping list, or be able give you access to a camera shot of your fridge from your phone. So if you're out shopping, you can figure out what you have or don't have. Sensors are being embedded into roads and on plants and other things to actually be able to track a wide variety of things, from moisture to heat and beyond. So vehicle and device location tracking has been a very, very big and growing market. We'll talk a bit about this BC company Sendum. So in a previous company I had, we did a lot of work with Sendum, where we built a asset tracking and a vehicle tracking software platform for being able to secure devices, but also track the movement of commercial vehicles to optimize them. Sendum here, here in Burnaby, builds devices and technology that allow, indoor locatable capabilities. So small devices that can then fit inside of packages or go embedded into a device to make sure that they're secured through a supply chain when they're shipped. Sendum's also developing technologies that can be in the top of a pill bottle so that a pill bottle can be detected when and where it is, temperature, but also when it's opened and closed, and transmit that data back to back to a home record to make sure that, say a patient is taking their pills. They're also building technology into transportation devices for organs to make sure that an organ that's being moved from an organ donor to a patient that needs it is being tracked on the most efficient timeline, so that they are actually routed through the helicopter, the plane, where it happens to be, to make sure that organ is preserved. So amazing technology, and there's now well over 15 billion devices connected to this Internet of Things, and it's growing beyond comprehension. The next technology to talk about is what we call 3D printing. So I know a lot of times in the school systems, you may even have some of these 3D printers, and so you may be very familiar with them or have tried them or played with them. You may have students actually creating objects with them. But again, just for definition, what is 3D printing? Well, it's a process by which you can make a three-dimensional solid object from a digital file and from some material into a machine. So these objects are created by laying down layer after layer of material until this object is actually created in 3 dimensions. So many applications now for this, whether it's on-demand items in manufacturing, or being able to rapidly prototype something, creating custom objects in whether it's eyewear, movie props. There's actually prosthetics being developed, toys. There are actually companies doing 3D replicated bones and dental products. It's quite amazing. We'll show a quick video here for Aspect Biosystems. They're again a BC-based company that is doing bioprinting and tissue engineering using 3D printing.
Aspect Biosystems is a Canadian biotechnology company building living 3D tissue solutions for the life science industry. Aspect's proprietary lab-on-a-printer platform is one of the most advanced tissue engineering technologies in the world, capable of rapidly 3D printing human cells with biological scaffolds to generate complex living tissues. Developing a useful 3D tissue begins with defining how the tissue should function, then conceptualizing how to construct the tissue to display the desired functions. Generating a biologically relevant 3D structure is essential to recreating lifelike function. Once the tissue structure is defined, the 3D bioprinting protocol is designed to enable the rapid and accurate fabrication of the living tissue. Aspect's unique lab-on-a-printer microfluidic technology enables switching between different cell types and scaffold components on the fly.
So I'll pause there. So that's incredible. The fact that in real time, different components can come together to create these 3D cells is quite amazing. Again, so many medical applications, bones, bones, cells, skin, all sorts of things. It's quite amazing. So move on to the next one here, quantum computing. Again, if you're in the STEM side of the world, you've probably talked about this a fair bit, or in physics and math. But what is quantum computing? Well, it's the ability to harness and exploit sort of these crazy laws of quantum mechanics to process information incredibly rapidly and at scale in a way that a traditional computer can't. So if you know about traditional computers, they use long strings of bits and bytes, which are encoded as zeros or ones, to turn things on or off very quickly to do calculations. A quantum computer, on the other hand, uses qubits or quantum bits to do things in a massively parallel way. Huge applications for this, factoring large numbers, genomic analysis, artificial intelligence. Real world applications include cryptography, code making and code breaking, for cryptographic secure transactions, but also simulating quantum systems, between atoms and molecules. We're very, very proud to have D-Wave as a local British Columbia company that was an absolute foundational company in this, a couple decades ago, and still remains a world leader. And we'll do a quick video on them as well, which will give you great examples of how this can be used.
I see quantum computation as being a tool that can solve problems that you could never otherwise solve.
In doing genomic analysis to help find better drugs.
Debugging large, complex systems.
To looking for bad guys in large amounts of data.
Space exploration.
Trying to optimize waterworks.
Building artificial intelligences that can help us solve very difficult, complex problems.
Building a quantum computer is a historic thing. And it's really like venturing into uncharted territory. There's no precedent here.
Quantum computing literally taps into our most fundamental understanding of the laws of nature.
In nature, there's this almost spooky phenomenon called quantum mechanics, where a thing can be in two states at the same time. And so the D-Wave quantum computer uses that strange property. What the quantum computer actually does is it's able to compare many possible solutions at once. So if you imagine a regular computer, if it was searching for a solution, it would have to go through every possible solution one by one, see if that's a good fit. What the quantum computer does is it kind of lays all the solutions down and compares them all at the same time, so it can pick out the best one.
The D-Wave system is built to solve discrete optimization problems. These are types of problems where you've got a load of constraints and you're trying to find the optimal answer to your set of constraints. Say you've had some kind of natural disaster and you've got a load of people who need help, and you've only got a limited amount of resources to go help them. So you've got a few lifeboats and a few helicopters. What you need to do is work out what order to send things and where to send things to save the most amount of people as possible. This is a hugely complex problem because there's so many possible different combinations of sending them in different orders. So this is the kind of thing that finding a fast answer is really important.
The D-Wave computer has two what I would say really sort of exotic operating conditions. We put our quantum processor into something called the dilution refrigerator, which cools it down to 10 millikelvin, which is about 100 times colder than interstellar space. And
I'll pause there. Just it's the rest of this is very fascinating, but it's quite incredible. Again, you can see the applications for this, but also in the video when you looked at the actual shape and the size and how these computers are built, they don't obviously look like a typical computer, and they have to have these very low temperature operating conditions to work. So quite amazing. And again, we're seeing massive implications and huge computing capabilities coming to market from quantum computing. So the final technology here in sort of our quick, again, top of the waves overview of technologies are wireless and 5G. Now we're all probably pretty familiar with a lot of these things and the beneficiaries of them. But just to define the two different things, wireless technology in general is where fixed or mobile devices, now have basically near ubiquitous access to fast data networks, whether that's through Wi-Fi or cellular data communication. So we're all familiar with our phones, our tablets, and our computers, be able to connect to extremely now high-speed Wi-Fi or even very high-speed cellular data networks. The cellular data network that is now the current most fastest is what we're calling 5G. Many of us maybe even have 5G phones now, and whether you've run a speed test on your 5G phone, incredible speed. So 5G stands for the 5th generation of cellular data communications. What's very compelling about 5G is if we've all probably lived through 3G, 4G, and now 5G, where we've seen speed bumps, 5G is kind of quite different. It's not just a speed bump, it's a dramatic increase in the number and resiliency of the connections that can occur on the network, and a reduction in the latency. So that's the speed you can kind of communicate within the network, and an increase in the reliability of the network. So what does this really all mean? It's not just to an average consumer, it may seem that it's simply a speed increase, but it's actually how fast devices and other things can operate on the network between each other. So huge values for this. 5G is really what is going to provide the true underpinning for autonomous vehicles, because autonomous vehicles on a road need to, if you fast forward and imagine a world where we do have autonomous vehicles driving around, they need to communicate between vehicles, between the vehicle and the road, between the vehicle and a back-end processing system, sensors, all sorts of things. And again, it's truly 5G that will allow that. The near instant video streaming, when again you're streaming down the highway, being able to have fast networks that are capable of handling the bandwidth, but also handing off the network signal as they drive. But really, this is where things like remote surgery become a reality. If you remember from our example earlier, around the mixed reality precision OS people who are doing surgery training, 5G will actually allow the next generation where you can actually have a doctor in one location putting her hands in surgical gloves, doing a surgery in a mixed reality world where that surgery is actually being done by a robot remotely, in a third world country or somewhere else. And it's this type of low latency, high bandwidth network like 5G that will allow that. And of course, we've got our Canadian telecom companies leading the way here. So that's the end of the technology overview. We've got a little section here we've added for this go around because it's been quite a year in British Columbia technology. So we call this little section the rise of the unicorns. If you've not heard the term unicorn before in the technology space or in the venture capital market space, a unicorn is referred to as a company that has achieved a valuation of $1 billion or more. In Canada, there haven't been a tremendous number of unicorns. In particular in BC, we haven't seen too many of them. In 2021, we've had 9, and that is unprecedented. And this speaks to the rapid growth of our technology market, the competitiveness of British Columbia as a technology industry, and how we are now seen again as a world leader and interacting with world leading companies. So just to run through this very quickly, Abcelera, again, a local AI drug discovery company, went public and last year, $4+ billion valuation. You may have seen them because they've got some COVID-19 therapeutics. They're now working with Moderna on a number of things. A spin out of UBC, just a phenomenal company. Blockstream is a blockchain technology company that manages storage and transfer of digital assets, $4 billion valuation. Clio is a legal law firm or legal practice management company, $2 billion+ valuation. They basically help to pioneer this whole new way of lawyers working. Dapper Labs, we've talked about, crypto, blockchain company with NBA Top Shots. They also created a platform called CryptoKitties a number of years ago, $3.5 billion+ valuation. I expect that to go up dramatically very soon. Galvanize was recently sold for $1 billion. They were previously ACL Technologies, ACL company. They are a security risk and compliance company. GeoComply is a fraud prevention cybersecurity company. Again, $1 billion+ valuation. Thinkific has gone public. They are a online education and course platform. They enable anyone, a business, to create an online course and and monetize that. Trulio, $2.1 billion+ valuation. They're an identity and address verification company doing what's called KYC, or know your customer, which is very, very important in every financial and banking transaction. And Visier, which is a people analytics HR platform, achieved $1 billion+ valuation. So again, unprecedented in British Columbia to have this many unicorns and this many created in such a short period of time. Again, just goes to show you how incredible our ecosystem has become. So we talked a lot about technologies. Let's now talk about some of the real, additional real world impacts of these things. Agricultural technology, or ag tech, so important, and in particular in the wake of COVID. When COVID first hit, the supply, and now even supply chain disruptions, difficulty in British Columbia. Something like 80% of our produce comes from outside of the province. So a lot of organizations like Save on Foods and others have turned to agricultural technology to say, how can we do things like using technology to improve the productivity of our agricultural assets, the profitability, the yield, and the sustainability of that. So much technology going into air, soil, and livestock sensors that provide real-time understanding of farms and crops, the ability to do kind of well-designed, genetically designed foods to address biological needs. So not sort of the GMO foods of the past that were all chemical driven, but really helping to create foods that are diverse and sustainable and help different individuals with different needs to thrive. But also agricultural robots and precision agricultural tools. So the ability to combine wireless networks with high sensitivity GPS location sensors to drive robotic tractors with high precision to either water, areas that need watering, or to, spray crops instead of, blanket spraying crops, only spray the crops that really need it. Companies like Semios here in British Columbia, that is a phenomenal company, done so well. They have a little box that goes at the end of plants on crops that actually can pull bugs in, and has a little sticky paper that the bugs stick to, and it takes a photo of the bugs and then uses artificial intelligence to discern the different types of bugs that are in there and what types, how many of them over what period of time, so that then again these crops can be sprayed or can be harvested at different times to improve the yield and the sustainability. Huge, amazing opportunity. Vertical farming, again, coming soon to things like parking garages near you. The idea that instead of having to build out on flat lands, you can now build up using all sorts of technology, hydroponics, different types of light and energy, reclaiming unused land to be able to take advantage of all sorts of different structures that may be unused in the past to grow crops. So what's really the power here is we can now bring crop growth out of rural environments into urban. So starting to see this urban food production to grow. So again, this idea of being able to grow food nearer to where it's consumed has tremendous, second and third and fourth order impacts, where now we can reduce waste, we can reduce, trucking costs, emissions, spoilage, all of these things, huge implications with vertical farming. And literally organizations are looking at parking garages. So when you start to fast forward and say, okay, if we can use, different kind of transportation, the SkyTrains of the world, autonomous vehicles, Ubers, other things where we can make our transportation more efficient, even down to scooters, we may not need parking garages the way we've needed them before. Imagine, if you have an autonomous vehicle that can drive you to work, drop you off, doesn't need to be parked idle for 8 or 10 hours. That vehicle can now go out and drive people around. You've now reclaimed that parking garage. What can you do with a parking garage? Well, you can put a vertical farm in it. All sorts of these things coming together to create tremendous benefits. Other interesting things here, again, mining industry so important in British Columbia. What is this picture? This is a company called Motion Metrics here in BC. That is a camera picture of a digger, those big diggers that go into the earth and grab a whole bunch of dirt and then dump it. That dirt then gets separated. So in a mine, when they're mining and digging, they're grabbing all the dirt. The items that are in the bucket that get dumped then get sorted and separated through a series of machines. If you take a close look at that image, if you can see it, at the top of the bucket are teeth, and one of the teeth is missing. So what's powerful about this Motion Metrics technology is it can detect using real-time video cameras connected to, over wireless networks, to artificial intelligence systems that can do object detection to say, hey, alert, a tooth has broken off of the bucket. We need to stop that bucket before it gets dumped into the harvesting equipment, because if those teeth end up in the harvesters, they can break the machines and jam up a production cycle, costing tens of thousands to millions of dollars in downtime, broken machinery, et cetera. So you can see these technologies all coming together in incredible ways. Another neat one here, I'll show you a quick video in the mining sector. I'll let this play for a minute. You can sort of see how some of these other technologies we've talked about in the last hour are starting to come together. So you can see the human in the bottom frame with the virtual reality glasses on, and he's got a controller in his hand. you can see here is this is a mining camp done in virtual reality, where they're adding layers and layers of data and now zooming in actual mining locations, looking around and being able to make sense of the mine from a distance. Look at the mining pits. Looking where all the holes have been, basically dug. Now layering in what's in the mines, et cetera, et cetera. So again, a phenomenal, use of all these, mixed reality technologies, the ability to have visual overlays, and now you can actually have someone look through all of these historical mining sites without having to fly someone up, put them in danger, send them down a mining shaft, et cetera. And that's Lamazoo, a BC company. This video I'll show you here is a manufacturing one about smart factories. This is not a BC company, but it's sort of the best video we could find on this. It's incredible to actually see how this is all being done. We'll run this really quickly.
The smart factory just got even smarter. This site in Heidelberg, which makes electrification products, combines advanced robotics with the power of the Internet of Things. It's a showcase of what ABB Ability, which brings all of ABB's digital products together under one offer, means in action. The production line is equipped with sensors to capture data about the products and machines at every stage of the process, while 7 ABB robots perform a variety of complex roles. The production stations work autonomously or together, adjusting their actions based on what happened at earlier stages of the manufacturing process. Cameras visually compare each component and trigger self-correction processes if any specifications aren't met. Each circuit breaker has a unique QR code, which enables full traceability from the factory to where it's installed.
So I'll pause there and kind of skip to the next slide. When you think about the level of automation there, these factories of the future are incredible. All these processes are controlled and managed autonomously using robotics. You can enable this concept of on-demand production, where we can build things that we need when we need them instead of having huge, long production cycles. This can then create much faster supply chain reactions to avoid having excess stock and helping to manage production in real time. This is now being combined with digital twinning so that you can actually try all these things out in software before they're rolled out. And then again, using wireless communication technologies and real-time communication can measure and manage these things. And often in these factories, the lights are turned off, saving electricity because there may not be any humans inside. When you bring this all together and think about, again, the world we've lived in the last 18 months, the ability for some companies that had adopted these technologies to quickly pivot into building PPE, masks, produce ventilators, all the things we needed, that was a godsend. 10 years ago, that would have been impossible for a production organization to stop, retool, and change. When we started seeing the inability for Canada and BC to get things we needed from our global supply chain partners, the ability for us to start to produce things locally, very, very important. So what we're starting to see again in the wake of COVID is more and more of these smart factories and small footprint mini factories being created and built that can start to build many, many things to bring production closer to home again. So, as a global, population, we went from building things locally to building things in low-cost centers to now really seeing the challenge of these supply chains when we rely on 1 or 2 countries to build so much. So it's all getting nearshored again or brought back. And we're also seeing that, 2 years ago, pre-COVID, the concern about, AI automation taking people's jobs was a big discussion. That narrative has flipped literally in the last few months when we're seeing that, the Port of Los Angeles right now backed up, and the supply chains, the slowdowns, the impact on inflation. We're now seeing everyone rush to how do we automate more, because they can't literally hire enough people to work in these factories, work at the, in these jobs to make the supply chain move again. So we're seeing again tremendous adoption, rapid adoption last few months again of these technologies that even 2 years ago where people were questioning to see whether they were going to be net negatives for jobs, but now they're tuning to be net positives to help us actually, build things we need to build and maybe address some of the inflation concerns that are happening. And then sort of finally in this section, close to home, how to use technology in industry, construction sites, local Vancouver company, SiteMax, doing amazing stuff with construction sites. So again, construction sites have historically been very low tech, lots of workers on the sites, building, measuring things, and that can lead to, all sorts of things, scheduling challenges, hard to track safety, hard to track time of, general contractors, subcontractors, subtrades. SiteMax, has done a phenomenal job locally and around the world of deploying their technology on smartphones, on tablets, on computers to help really introduce huge technology gains into the construction, industry. And they have such, high uptake now. One of the best examples of what they're doing is in safety tracking. When a worker sees something that's not right on the site, they can take a photo of it, upload it immediately. They can have a site inspector come, fix something, address it so someone actually doesn't get hurt. Phenomenal innovations. So kind of winding into the really important part of all this, we've spent the time today talking a lot about industry statistics, really hopefully trying to demonstrate and convince you and really show you how important and how huge an opportunity it is for our youth to get into the technology field, talk a bit about some of the really compelling, interesting, and mind-boggling technologies and how BC again and Canada are world leaders in these things. Now let's talk about what it actually means to work in tech. Well, I'll be the first to say that working in technology is fun, impactful, and rewarding. I've been in tech for almost 25 years. I've had the advantage and the opportunity to work across all sorts of industries, mobile, wireless. I work in AI now, working on some crypto things. It's fascinating and super fun. But beyond that, there's a lot of upside. Again, we've talked about the higher than average pay scale for tech careers. But not only that, is that these skills in technology are highly transferable, within BC, within Canada, and around the world. And again, if you've learned and trained in BC or in Canada, highly desired anywhere in the world. So if our young people today want to go and travel, which they should, live elsewhere, if they get trained here, they have no shortage of opportunities anywhere. But also these skills are not just, it's not just, you go to work for a company for 25 years anymore. These skills are transferable to many, many different organizations across a wide variety of industries. So there's huge flexibility in job opportunities. We've talked a bit about the environment, the ability to, a lot of, back in the office, a lot of tech companies bring in lunch. You can bring your dog to work, your pet to work. Work from home was a thing well before the pandemic. And now as the pandemic kind of moves on here and continues, we are seeing a lot of mixed working. So the ability to work from anywhere. I have colleagues that have upped and moved to the beach in Mexico and are running big organizations from different locations, and they're going to come back in a few months. It's phenomenal, but it's very fast-paced, high energy, tons of opportunity. And as a real-world example, graduates from UBC and SFU with computer science degrees in artificial intelligence are commanding upwards of $150,000 a year for early starting salaries. So huge opportunities, but beyond that, you can actually impact the world, whether it's medical technologies, whether it's some of these compelling new decentralized finance technologies and beyond. It's really fun to be involved. Most importantly, working in the tech industry is not just about programming and engineering. Of course, that's a big part of it, but here are just a couple of dozen roles in the tech sector that are technology oriented. Look at some of the highlighted ones. We've talked, computer programming, of course, but quality assurance and testing, huge and really rewarding for individuals that may not want to go down an entire engineering route, but are very specific. This is actually a huge, massive beneficial opportunity for a lot of our youth that have autism. Companies like SAP have a big office here globally in Vancouver, have an autism at work program that seek to actually, they have a 1% commitment to hiring neurodiverse individuals around the world. And often neurodiverse people do very, very well in quality assurance testing and computer programming. So huge benefit there. Computer and network support, not just programming, but doing IT network, cybersecurity management, an area I'm working in now. You can't even hire enough people in that area. And often that's, a different skill set. It's not just a computer engineer, it's someone who understands how networks work and think in a different way. But also going to the right-hand column, graphic designers, people that are creative, that can actually, adapt their digital art to the world, being able to design software interfaces, making them very usable. Client success, someone who gets along well with people, understands and can empathize with other individuals to help them be successful. And that's similar to customer support, but also marketing coordinators, marketing managers, social media marketing, sales operations, business analysts, project managers, and product managers. These people tend to be very, detail oriented, very organized, thoughtful, but maybe more on the human or business side than actually writing code. Dozens and dozens of job types in the sector. But also, when you are adept at using technology, it spans all sorts of jobs, from working in admin to the C-suite, a chief operating officer, a chief executive officer. Nowadays, the ability to use and understand technology is a must, and this is only going to go up. Whether it's an administrative assistant that understands how to use, Microsoft Office or Google Office tools, to scheduling mobile apps, to marketing staff. The average marketing team now uses between 15 and 30 different technology tools just to do their job, whether that's email systems, social media marketing systems, website, e-commerce, tracking, automated account management, customer support tools, automated project management tools, etc. And we're seeing this world of no code tools that allow anyone, even if you don't have coding capabilities, to do sort of pseudo computer programming without them having to even know that. And in the C-suite, building dashboards, using scheduling tools, communication tools, it's a daily requirement to understand how to use technology. So these roles are different across startups to multinationals, but the fact remains that you still need technology skills. Beyond that, what's really interesting, and one of the reasons we are so compelled to work with teachers and other educators, is that students today, our kindergarten through 12, are digital natives, which means they've grown up with technology on a day-to-day basis. They are exposed to having had their smartphone, access to an iPad, access to the internet from day one. So they get it. They understand that they can ask a question and get an answer instantly, and they have access to the world's information whenever they need it. What's also interesting is that games like Minecraft are actually teaching young people basic coding skills, basic logic and problem solving. If you've used Minecraft, or your kids use it, or you've seen it used in a classroom, you can, building a little world and then making lights turn on by running wire, and if this, then that type of logic is fundamental to Minecraft. And that's basically pseudo programming or coding logic. But for young people, using technology is not foreign or scary to them. They are willing just to jump in and try things, and that's really helpful. But what's also really important, and really germane to our discussion today, is that soft skills are also absolutely critical. So it's not just hard skills of math and computer science, it's soft skills. So important. And a really interesting stat from 2020, the World Economic Forum came out with the top 10 skills demanded in 2020. This is extended. Problem solving, critical thinking, creativity, people management, coordinating with others, emotional intelligence, judgment, decision-making, service orientation, negotiation, and cognitive flexibility. So these are the top 10 skills. Now, underneath this, you may have math and science, but you don't see that in here. Really, it's all about, quite often being able to work with people, understand people, empathize with them, make good decisions, be intelligent, gather data, and really, deal with that. And what's so interesting is it matches very well with the BC curriculum in the schools. Now, you guys will know this far better than me, but there's a really, high level of overlap here in what the BC curriculum pushes and we're imparting on our students than what the skills are required today. So we're very well positioned here. And really, just to finish off here, this is actually a neat stat from Australia that applies very well to Canada. If we shift just 1% of our workforce into STEM roles, we'll drive billions of dollars in GDP growth. So whatever we can do here to help students understand the opportunity in technology, we're very, very much committed to. you.